Hello friends, welcome to BHU Mathematics. In this video, we will discuss a question from calculus of two variables. We have to solve this integral, double integral xy upon square root of 1 minus y square dx dy over the first quadrant of the circle x square plus y square equal to 1. So this is unit circle and the options are 1 by 2, 1 by 3, 1 by 5 and 1 by 6. So let us just look at this. So this is our unit circle and we have to find out the integral over the first quadrant of this. So in the first quadrant, so this is the given region, right? And we will convert this integral into polar coordinates. So in this quadrant is x is equal to r cos theta, y is equal to r sin theta, and now look at this. Now theta is the angle between this x axis and the y axis here. So this is the angle. So theta is varying from 0 to pi by 2. And now this r is varying from this, r is the radius of this circle. So it is varying from 0 to 1, right? Because it is a circle of radius 1. So r is varying from 0 to 1. So these are the limits of r and theta in the first quadrant. So we will use this. Now under this polar coordinates, the given integral is, so let us write it, integral xy upon square root 1 minus y square dx dy is equal to integration theta is from 0 to pi by 2, r is from 0 to 1. Now x is equal to r cos theta, y is equal to r sin theta divided by square root of 1 minus y square is r square sin square theta. Now the important thing is, in this dx dy, we must replace it by r dr d theta. So r dr d theta in place of dx dy. Now we have to solve this integral, and the value of this integral is same as the value of this integral. So let us solve it. So this is just square root. Now these limits are constants for r and theta, so I can just take this here. So r is from 0 to 1, theta is from 0 to pi by 2. Now this is r square cos theta sin theta divided by square root of 1 minus r square sin square theta, then r dr d theta as it is, right? Now I will just first integrate with respect to theta. So let us write d theta here and r dr here. So let us find out this integral first. So that means this part. So to find out this integral, let us put 1 minus r square sin square theta is equal to, say, u. Then now just change the limits of integration. Now we are integrating this with respect to theta, so treat r as a constant. So when you differentiate this, we will get this is minus r square as it is, because we are integrating this with respect to theta. Now this is, now differentiate this, so this is 2 sin theta cos theta d theta is equal to du, right? Now let us just look at here. So we have this r square cos theta sin theta d theta. So from here r square sin theta cos theta d theta is equal to du by minus 2, right? So this 2 minus 2 here. So this integration is just equal to r as it is 0 to 1. Now what are the limits of this theta? So when you put this theta is equal to 0, we get sine 0 is 0, so this is 1 minus 0, so u is 1. Then when you put theta equal to pi by 2, then it is sine pi by 2 is 1, so 1 minus r square, right? So change this, so it is just 1, u is from 1 to 1 minus r square cos theta sin theta d theta is minus du by 2, right? Then this square root is just square root of u, because u is equal to 1 minus r square sin square theta from there. So we just have to find this r dr as it is. So let us solve this. So just look at this. This is just equal to, I will first find this integral. So integral u from 1 to 1 minus r square, this is just 1 by root u, take this 1 by 2 outside. Now this is minus of this integral, and this is a smaller number than 1, so change this 1 minus r square to 1, right? So this integral is just this. Now find out this integral. So this is just 1 by root u is same as u raised to minus half, right? So this is just equal to, now integral of u raised to n du is equal to u raised to n plus 1 by n plus 1 plus c. So use this formula. This is just u raised to half divided by half, and the limits are from 1 minus r square to 1, and this 1 by 2 as it is. Now this 1 by 2 will get cancelled with this 1 by 2, and this is just same as u square root of u, it is from 1 minus r square to 1. So this is just square root 1 minus square root of 1 minus r square, right? So let us put this value here. So this is just equal to, r is from 0 to 1. Now this integral is same as this. So this is square root 1 is just 1, square root of 1 minus r square into r dr as it is. So let us solve it. Now this is just same as, now multiply here by r. So this is r, right, and dr as it is. So this is just equal to 0 to 1 r dr minus 0 to 1 r square root 1 minus r square dr, right? So solve this. Now again we have to do the substitution for this 1 minus r square. So substitute 1 minus r square is say t, then this is just equal to, now find out first limits. So when this r is equal to 0, we have t is equal to 1 minus 0 square is 1. Then when r is equal to 1, t is equal to 1 minus 1 square, which is 0. So this integral r square root 1 minus r square dr from 0 to 1 is just same as t is from 1 to 0. Now this, when you differentiate this, you will get this minus 2r dr is equal to dt. So r dr is equal to dt by minus 2. So r dr is equal to minus dt by 2, and this square root of 1 minus r square is just equal to square root of t, right? Now let us just solve this. So this is, here it is minus 1 and the limits are from 1 to 0, so we can just swipe them. So it is just, this 1 by 2 is a constant, take it outside. This is t runs from 0 to 1 square root t dt, right? So this is just equal to 1 by 2. Now square root of the integral of square root t is equal to t raised to 3 by 2 divided by 3 by 2 limits are from 0 to 1. So this is just equal to 1 by 2. This is 3 by 2. So it is 2 by 3. Now 1 raised to 3 by 2 is just 1. 0 raised to 3 by 2 is 0. So this limit, this value is just equal to 1 by 3. Right. So this integral is just equal to 1 by 3. Now the integral of this is just r square by 2 and limits are from 0 to 1. So it is 1 by 2. So this is just equal to 3 minus 2 is 1 divided by 6. So the answer is this fourth option. Let us solve another question. This is question number 46 and the previous question was the question number 45. This question says that by changing the order of integration in the integration from 0 to 4 from x to 2 root x f of xy dx dy, it can be expressed as, there are 4 options with various combinations of these limits. Now let us solve this. Now let us just look at this region. So here x varies from 0 to 4 and y varies from x to 2 root x. Okay. So let us find out the region. So y is equal to x and y is equal to 2 root x. So let us draw. First is y is equal to x. So y is equal to x line, right? So, and this y is equal to 2 root x. Now we want to find out the intersected region. So let us equate these two, because y is equal to x and y is equal to 2 root x. So x is equal to 2 root x, right? These two values are same. So square on both sides, it is x square is equal to 2 square into root x square. So it is 4x. So x square minus 4x is equal to 0. So x into x minus 4 is equal to 0, and this gives us x equal to 0 and x is equal to 4, right? But on these two curves we have x is equal to y or y is equal to x. So y will be same as, when x is equal to 0, y is 0. When x is equal to 4, we have y is equal to 4. So the points of intersection is just x comma y is equal to 0 comma 0, and for x equal to 4, y is equal to 4. So 4 comma 4, right? Now 0 comma 0 is here, origin, and 4 comma 4 is, let us say here it is 4. So 4 comma 4 is here, right? This is 4 comma 4. And now let us just look at this. So y is equal to 2 root x. So square on both the sides, we will get y square is equal to 4x. So this is just x is equal to y square by 4, right? So this is just parabola like this, right? But now look here, this is bounded region and we have to just find the integral on this region. So this is our region. Now just look at this region. Here the limits are just, this is y is equal to 2 root x, this line is y is equal to x, then we have a point 4 comma 4 here, and we have 0 comma 0 here. Now the next thing is, this x varies from 0 to 4, right? So this is about this integral. Now change the order of this integration. So we have to change this order, means you write y in terms of constant limits, so, and x in terms of y. So for this, let us just, now this region is just same as we are taking this vertical strip, right? Because the y is varying here from x to 2 root x. So we have to take the horizontal strip. So draw the region as it is. And now let us change this order. So here it is 4, 4. So take the horizontal strip like this. Now change the limits. So here x is from 0 to 4, right? X is from left to right. So now we want the limits of y to be constant. So y, the limits of y are just from bottom to top. Now it is here it is 0, and on this y-axis it is 4, right? Because this curve intersect at 4, 4. So y is varying from 0 to 4, bottom to top, and x is varying from left to right. But now let us find out these curves in terms of x, in terms of y. So y equal to x means x is equal to y. Y is equal to 2 root x means just square on both the sides. So y square is equal to 4x. So this gives x is equal to y square by 4. Right. So this curve is same as this. So x is equal to y square by 4. Right. And we are taking this horizontal strip. Now along this find out the limits of x. So limits of x is just you take this limits from left to right for x. So when you start from left, the first time we hit this curve, right, from here, and then this curve. So from left to right, this x changes from y square by 4 to this is x is equal to y. So y square by 4 to y. So y is varying from 0 to 4. So 0 to 4, but it is 0 to 2. So this is clearly not true. Now x is varying from y square by 4 to y. So y square by 4 to y. So this is the correct option. Thank you.